So now we've talked about how the cache works for updating normal files from the cache. Now the whole app cache system is actually very complex. It's a very complex algorithm that the browser goes through to get files out of the cache, figure out whether it should update the cache, check the different sections in the file. We do want to talk briefly about the network section for files that always need to be loaded from the network. So let's go take a look at that. The network section was supposed to make it easier to build applications that were occasionally online, but it turns out that's pretty hard to do. As we talked about before, it's hard to answer the question definitively if you're online or offline. One common thing to do is in the network section, at the bottom, to put a star, or even just to only have a star here. This basically means anything that we haven't specified already further up in the application cache, in the cache section, you should just go to the network for. This actually isn't a great thing to do. If you have any blocking resources in your file, or in your application, that haven't been listed in the cache file, it's going to sit there and wait until it times out. So what you should really do is develop without that network star, even if you add it later. That way, your cache updates in the console will actually show you if you're missing files. Now that our application logic and our resources are stored in the app cache, let's talk about how we store data locally. There are several different ways to store data locally, many of which have developed over time. So let's cover each of these briefly. Local storage is the oldest and most basic of the storage APIs. It lets you get and set key-value pairs and iterate through all the keys. However, each value is just a string, and each domain can only store a total of between 2 and 5 megabytes in local storage, depending on the browser. There's no real searching capability. You can index through all the keys one at a time, or you can ask for the value associated with a particular key, but that's basically it. The local storage API is really simple to use. Take a look at how you can store an item using setItem, retrieve the value for a particular item with getItem. You can remove one key value pair with a removeItem, iterate through all the key value pairs with length, key, and getItem, or clear the entire local storage system. Now that our application logic and our resources are stored in the app cache, let's talk about how we store data locally. There are several different ways to store data locally, many of which have developed over time. So let's cover each of these briefly. Local storage is the oldest and most basic of the storage APIs. It lets you get and set key-value pairs and iterate through all the keys. However, each value is just a string, and each domain can only store a total of between 2 and 5 megabytes in local storage, depending on the browser. There's no real searching capability. You can index through all the keys one at a time, or you can ask for the value associated with a particular key, but that's basically it. The local storage API is really simple to use. Take a look at how you can store an item using setItem, retrieve the value for a particular item with getItem. You can remove one key value pair with a removeItem, iterate through all the key value pairs with length, key, and getItem, or clear the entire local storage system. To see the key value pairs that are stored for a particular site, or scheme host port combination, you can open up the Chrome Developer Tools, go to the Resources tab, and select Local Storage. Note that there's local storage, which persists across reloads, and session storage, which is the same API, but it's isolated by tab, and it's cleared at the end of the session. So whenever the page is closed down, the session storage goes away. Now, remember, you can only store text in local storage, so if you wanted to store an image or some other binary data type, you'd have to first base64 encode it. And of course, you only get typically about 5 megabytes per domain, so you're not going to be able to store very much. So now it's your turn. Use local storage to store the value bar for the key foo. Great job. It really is just that easy. Local storage is widely supported across browsers, but as we pointed out, it does have some downsides. It's a great way to get simple storage for persistent data like user settings or user's profile strings, but you really don't want to try to use it to store complex data like binary files or structured data. For that, you need a more complex storage system, like WebSQL or IndexedDB. WebSQL provides a SQLite-based database directly in the browser. You can use SQL queries to access data and define relationships, and you can have structured data in your value storage as well. Now, this is significantly more complex than the simple and limited key-value storage in local store. However, there's two main problems with it. The first problem is, although this API is available in Chrome, Safari, and Opera, and iOS Safari in the Android browser even, it's not available on IE or Firefox. The second problem is clear from the specification, which is no longer being maintained. In short, WebSQL is a dead end. It's out there in Chrome, the Android browser, Safari and iOS Safari, and Opera, but it's not available in IE or Firefox, and it's likely that it never will be. So what should you use if you need a complex data storage system? Well, there's one more system, the Indexed Database API, also called IndexedDB for short. Indexed Database was designed in response to WebSQL and its SQLite variant. Indexed Database is not a SQL API, it's a simpler index storage system on which you could build an optimized query implementation, like a SQL variant. This means it isn't optimized to a particular query system. Instead, when you create your database, you define what indexes you want to use. If you've never done database storage before, IndexedDB may take a little bit of getting used to, but it's actually pretty straightforward. The spec itself has some really good examples in it. This code is based on the spec. First, you need to open your database, and you need to be prepared to initialize the database if it hasn't been opened before. When you initialize the database, you can define the indexes in the database, that is, what attributes are easily searchable. You can change this later too, you just have to upgrade the database. And of course, you can inspect the databases in the developer tools to see what's going into the IndexedDB store and check to make sure it's organized the way you want it. Just go into the Resources tab, select IndexedDB, and there you go. You can see your objects right there. If you expand them, you can even see the values. So why should you use IndexedDB over WebSQL? Well, the good side is that IndexedDB is supported in Chrome, including Chrome for Android, as well as Firefox, IE, and Opera. The downside is that it's not supported in the old Android browser or in Safari. So there are going to be a bunch of mobile users out there that don't have IDB support for a while. Of course, there are a bunch of mobile users out there that aren't going to have WebSQL support either. So what's a web developer to do? Well, in general, I like to recommend trying to do the right thing, but pragmatically making it work in tough situations. The answer here is write to IndexedDB, but use a polyfill so it will work on WebSQL browsers. A good polyfill to use is the IndexedDB shim. There's a link down in the instructor notes. Writing your code this way, you can write good IndexedDB code, but it'll still work on Safari or other browsers that don't yet support IndexedDB. But let's bump up a level and talk about what you might want to use local storage to store. As I mentioned before, you probably want to use it to store user settings, but any data that may be useful in a different session of your application is probably useful to cache in IndexedDB or local storage. Finally, an important way to think of this is anytime you call a network API, you probably want to cache that response in IndexedDB or local storage so you can get it back later. When you're offline, this can be particularly useful because you already have the data from a previous session cached. In our conference app, for example, each of the data models is being loaded from a JSON file on the server. In the original incarnation, these files are loaded every time they're needed, just relying on HTTP caching to minimize the network transfers. When I initially made an app cache for the conference app, I just app cached the JSON files, since of course they need to be there to run the application. However, it would make more sense to cache the data here in index database for a couple of reasons. First, it can do indexed lookups, so I can have a table for speakers, a table for sessions, have them easily cross-reference items in each of them, and make it easy to search for an entry. Secondly, we can get the structured data directly out of the database, rather than having to parse the JSON text file each time. We can then provide a synchronization system that occasionally makes network requests to refresh the data objects, or updates on load, or when an unrecognized speaker is found. One final reminder, though. Keep in mind as you design your application that if the user clears their data from the machine, any data stored locally is going to be deleted, so you shouldn't store the only copy of important data on the client. Local storage is really just intended to be used as a cache. As you can see, there are a lot of complexities in making offline-capable web applications. The key thing to understand is that in the mobile world, offline is not a feature, it's a necessity. You need your applications to work seamlessly, regardless of network conditions.